Namaskar. Today we will study about linear equations in two variables and its application in real life situations. The possible number of solutions of a linear equation in two variables and the graphical interpretation of such equations. Let us first recall the concept of a linear equation. A linear equation is that equation in which each term can have the highest power of the variable involved as 1. For example, x plus 5 is equal to 0, or y is equal to 3, or 3z minus 7 is equal to 23. Since these equations involve a single variable in its formation, therefore these are called a linear equation in one variable. We also know that these equations give a single value of the variable entitled for specifying simple situations in practical life and finding the solution of the given problem. For example, if 5 is added to a number to get 0, then the equation x plus 5 is equal to 0 represents the given situation, and on solving this equation, we get x is equal to minus 5. Let us consider another situation. If 5 times the age of Priya is 25, then what is her present age? This question can be handled by assuming the present age of Priya to be x, and according to the given condition, 5 times x is 25, which can be expressed as 5x is equal to 25. This equation is again an example of a linear equation in one variable. Solving 5x is equal to 25, we get x is equal to 25 upon 5, that is 5. Here, the value obtained of the variable x is 5, and it is a unique value, for no matter how many times we solve it, we cannot get any other value of x from the given equation. Graphically, these equations represent a line parallel to y-axis or parallel to x-axis on a Cartesian plane and always give a unique value of the variable. Now, the question is, why do we need to study about a linear equation in two variables? For this, let us imagine a little more complex situation like a boy Ravi wants to purchase few pencils and pens. He goes to a stationery shop and finds that he has only rupees 24 in his pocket. The shopkeeper tells him the cost of one pencil is rupees 3 and that of one pen is rupees 4. Now, Ravi has to decide how many pencils and how many pens his pocket allows to purchase out of rupees 24. This kind of situation cannot be expressed without the help of two variables, as here we have to deal with two different articles. To decide the number of different articles to be purchased, we need to express the two variables in a linear combination. So, let us try to solve the above problem with the help of a linear equation in two variables. Let us assume the two variables to be x and y. Let us now see how this situation can be expressed in the form of a linear equation using two variables. Let us assume the number of pencils be x and the number of pens be y. Then the cost of x pencils will be 3x and the cost of y pens will be 4y. Therefore, the cost of x pencils and y pens together will be 3x plus 4y. Since the total sum is 24, therefore, the equation will be 3x plus 4y is equal to 24. The other way to write the above equation is 3x plus 4y minus 24 is equal to 0. This way, we have formed a linear equation in two variables. The general expression for this form is ax plus by plus c is equal to 0, where a, b and c are any real numbers. Comparing the equation we have formed above with the general form, we get a is equal to 3, b is equal to 4 and c is equal to minus 24. Now, let us try to find out the values of x and y which satisfy the given equation. We can clearly observe that x is equal to 0 and y is equal to 6 is one of the solutions of the given equation, as these values of the two variables satisfy the given equation. Let us verify this by putting the values of the variables. Putting x is equal to 0 and y is equal to 6 in 3x plus 4y minus 24 is equal to 0. Then 3 multiplied by 0 plus 4 multiplied by 6 minus 24 is equal to 0. That is 0 plus 24 minus 24 is equal to 0, or 0 is equal to 0. Hence, verified. That means Ravi can purchase 6 pens only out of rupees 24 and drop the idea of purchasing pencils, as the value of x comes to be 0. Can he find any other set of solution? Of course, as x is equal to 8 and y is equal to 0 is another set of solution for the same equation. Let us verify this again. Let x is equal to 8 and y is equal to 0 in 3x plus 4y minus 24 is equal to 0. Then 3 multiplied by 8 plus 4 multiplied by 0 minus 24 is equal to 0. That is 24 plus 0 minus 24 is equal to 0, or 0 is equal to 0. Hence, verified. That means Ravi can purchase 8 pencils only in rupees 24 and drop the idea of purchasing pens, as the value of y comes to be 0. Let Ravi try for more solutions. We can observe that x is equal to 4 and y is equal to 3 satisfy the given equation equally well, and hence form the third set of solution for the given equation. Putting x is equal to 4 and y is equal to 3 in 3x plus 4y minus 24 is equal to 0. That is 3 into 4 plus 4 into 3 minus 24 is equal to 0. That is 12 plus 12 minus 24 is equal to 0, giving 0 is equal to 0. In this case, Ravi can enjoy purchasing both the articles, pencils and pens out of rupees 24. He can purchase 4 pencils and 3 pens in rupees 24, distributing the whole amount in equal halves, that is rupees 12 for each item. There would be, in fact, many other values of x and y satisfying the given equation. But since x and y both denote the number of items, therefore only the integral value of the variables will be acceptable and the non-integral values of the variables x and y will be rejected. Whereas in some other situation, there can be no such restriction. Let us now consider another example where there is no such restriction in picking the values of the taken variables. Suppose we are planning a road trip that involves two types of terrain: highway driving, where our car consumes fuel at 6 liters per 100 kilometers, and mountain driving, where it consumes fuel at 10 liters per 100 kilometer. We have a fuel budget of 18.4 liters for the entire trip. To depict this situation mathematically, we let x be the distance in kilometers driven on the highway and y be the distance in kilometers driven in the mountains. Then the linear equation representing the given situation will be 0.06x plus 0.10y is equal to 18.4. Now, let us try to find the solution. Suppose we drive 120.5 km on the highway taking x is equal to 120.5. Substituting into the equation 0.06 multiplied by 120.5 plus 0.10y is equal to 18.4. 7.23 plus 0.10y is equal to 18.4, which gives 0.10y is equal to 11.17 and finally gives y is equal to 111.7. So, taking x is equal to 120.5 km, we get y is equal to 111.7 kilometers. Here, x is equal to 120.5 and y is equal to 111.7. Both are non-integral values that satisfy the equation. In fact, in this example, we can find uncounted set of values for the variables x and y, both integral and non-integral, as there is no restriction for the distance covered to be in integers only. It can be in fractions or decimal as well. But since a distance cannot be a negative measurement, therefore, we should not pick those values of the independent variable x which may give a negative value of the dependent variable y. Now, let us define the two different types of the variables. The variable whose value is arbitrarily chosen is called an independent variable, and the variable whose value is calculated is known as the dependent variable. In general, x is taken as the independent variable and y is taken as the dependent variable. Let us consider one more practical problem in real-life situation. The total cost of 5 kgs of mangoes and 2 dozen of bananas is rupees 620. Now, answer the following questions. First, if the cost of 1 kg of mango is rupees 110, then find the cost of 1 dozen of bananas. Second, if the cost of 1 dozen of banana is 3 by 5 of the cost of 1 kg of mango, then find the cost of 1 kg of mango and 1 dozen of banana. Let us find the solution of the first part. Let the cost of 1 kg of mango be x and 1 dozen of banana be y. Then, according to question, 5x plus 2y is equal to 620. Now putting x is equal to rupees 110. Then 5 multiplied by 110 plus 2y is equal to 620. Then 2y is equal to 620 minus 550, which gives 70. So, y is equal to 70 upon 2 is equal to 35. So, assuming the cost of 1 kg of mangoes as rupees 110, we get the cost of 1 dozen of bananas to be rupees 35. Now, let us find the solution of the second part. Here, the cost of 1 dozen of banana is 3 by 5 of the cost of 1 kg of mangoes. That is, y is equal to 3x upon 5. Putting these values in 5x plus 2y is equal to 620, we get 5x plus 2 multiplied by 3x upon 5 is equal to 620. Taking LCM, we get 25x plus 6x is equal to 3100, which gives 31x is equal to 3100. That is, x is equal to 100. Now, y is equal to 3x upon 5. That is, 3 into 100 upon 5, that is 300 upon 5 is equal to 60. Therefore, by the given relation in x and y, we got the cost of 1 kg of mango to be rupees 100 and the cost of 1 dozen of banana to be rupees 60. Let us see the graphical interpretation of a linear equation in two variables. We can recall that a line is a collection of infinite number of points. Then there must be infinite points lying on the given line, and so giving its infinite solutions. Since all linear equations in two variables represent a straight line in a two-dimensional plane, and every solution of these equations denote a point lying on that line, we naturally get infinite solutions of an equation. Though we pick only those points which have a practical meaning for that particular problem. As in the above example of the boy Ravi, we obtained solutions 0, 6, 8, 0 and 4, 3 are the points lying on the line 3x plus 4y minus 24 is equal to 0. Only these solutions make a practical sense in the given example, so we pick those only. And in another example of traveling, the obtained solution 120.5 and 111.7 denote a point on the line 0.06x plus 0.10y is equal to 18.4, one among the infinite points lying on that line. Let us draw the graph of a linear equation. Let the linear equation be x plus y is equal to 7. For this, we choose 2 points on the line using the shown table. Here, choosing the value of the independent variable x arbitrarily, we get the corresponding value of the dependent variable y. Let us recall that minimum 2 points are required to draw a line. When x is equal to 0, the equation x plus y is equal to 7 gives y is equal to 7. So, we obtain the point 0, 7. When x is equal to 7, the equation gives y is equal to 0 and we get the point 7, 0. Joining these 2 points, we get the graph of the line x plus y is equal to 7. We observe that the line drawn cuts both the axes at equal distance from the origin. Let us draw the graph of equation y is equal to 2x. By taking the value of x is equal to 0, 1 and minus 1, we get y is equal to 0, 2 and minus 2 respectively as shown in the table. So, the points obtained are 0, 0, 1, 2 and minus 1, minus 2. And the graph is as shown on the screen. Similarly, if we make the value table for the line y is equal to 5x, which is of the similar structure, we observe that 0, 0 is a point obtained again. We observe that first, any line having the equation y is equal to mx, where m is any real number, will have one of its solution 0, 0 and will pass through the origin always. Second, the equation of the form x plus y is equal to c, where c is any real number, represent a line intersecting both the axes at equal distance from the origin. Let us now discuss the life skills which relate to this topic. In analyzing a given equation and finding its solutions, the skill of critical thinking and problem solving is involved. In forming a linear equation from a given situation, both critical thinking and decision making is involved. In framing a word problem from a given linear equation, critical thinking is involved. Let us try these questions to check our learning. Question number 1. In the countries like USA and Canada, the temperature is measured in Fahrenheit, whereas in the countries like India, it is measured in Celsius. The relation between both is given by the following linear equation, that is, F is equal to 9 upon 5c plus 32. Based on given information, find A. The temperature in Fahrenheit when it is 30 degrees centigrade. B. The temperature in Celsius when it is 95 degrees Fahrenheit. C. Draw the graph of the linear equation above using x-axis for the Celsius and y-axis for Fahrenheit. Question number 2. The taxi fare in a city is as follows. For the first kilometer, the fare is rupees 8 and for the subsequent distance, it is rupees 5 per kilometer. Taking the distance covered as x kilometer and total fare as rupees 5, write a linear equation for this information and draw its graph. Now we conclude as a linear equation in two variables has a general equation ax plus by plus c is equal to 0, where a, b and c are any real numbers. These equations help us to handle many complex mathematical problems in real-life situations. Graphically, such an equation represents a straight line in a two-dimensional plane giving infinite number of solutions, and all its solutions represent the point lying on the line. That is all about for today. Hope this video has made a clear understanding about a linear equation in two variables. Thank you.